Here the ratio of two integrals is given, so we have to find the relation between these two integrals, right, in the numerator and denominator. Now in the numerator we have integral with limit 0 to 4 pi, and denominator we have limit 0 to pi, so that is the only difference. Let us simplify only the numerator integral. So that has limit 0 to 4 pi, so we can split it into 4 parts, like 0 to pi, pi to 2 pi, 2 pi to 3 pi, 3 pi to 4 pi, and then add all these integrals. Alright, so let us simplify only the numerator part. See, I am taking the numerator integral as, say, I. So the integral I, so that equals integral 0 to 4 pi, okay, whatever in the integrand is, I am not writing that. So that equals, that is split into 4 parts, right, 0 to pi, whatever it is, and then pi to 2 pi plus 2 pi to 3 pi plus 3 pi to 4 pi. Okay, so we have split it into 4 parts. Now let us simplify each one separately. Now this we will leave as it is, because this is what is given in the denominator, so that matches with the denominator. So let us give it some name, right? So we can call this integral, say, I1. So this is some I2, okay, so this is I3, this is I4. So I1 is what we need, because that is what is given in the denominator. Actually what we need to find is I numerator divided by I1, I by I1, so that's what is required. So I1 is left as it is. Now I2 is simplified now. Okay, let's simplify I2. So what is I2? That is this integral. So pi to 2 pi e to the power t sine to the power 6 at plus cos to the 4 at dt. So let us simplify this. See, we have to add these two integrals. Okay, all the four we have to add. To add two integrals, the limit should match, right? Here 0 to pi, here pi to 2 pi, so limits are different. Now we have to make the limits equal in these two cases. What do we have to do? We will do some simple substitution. Let us substitute some x equal to t minus pi. So why do we do this substitution? Because when you do this substitution, so what is the lower limit? Pi minus pi, 0. And the upper limit is 2 pi minus pi, that is pi, so that will match with this limit, right? So that's why we do this substitution. So what will happen? So this I2 will become, so what is this? Pi minus pi, 0, and then 2 pi minus pi, so that is pi, and e to the power t, but t is pi plus x. And what about this one? Sine to the power 6. What about this value? A multiplied by, so t, but t is pi plus x. But what is sine pi plus x? Or sine 2 pi plus x? Or sine 3 pi plus whatever, so that will give you the same value, right? Because the power is even, so whichever quadrant it lies in, it doesn't matter, because the power is even. Sine pi plus x is minus sine x actually, but the power is 6, right? Even power, so it doesn't matter minus or plus. So pi plus 6 or 2 pi plus 6, 3 pi plus 6, anything doesn't matter, as long as this a is an integer, right? If a is an integer, so it will give you the same value. So sine to the power 6, so directly we can write it, so that is ax. Similarly here also even power, cos to the power 4 ax, and dt is same as dx. Okay, dt is same as dx, so that is the value. Now what you do? So here you can take this e to the power pi out, right? E to the power pi multiplied by e to the power x. So if you take that out, e to the power pi, and then we get this integral 0 to pi e to the power x, again same value, sine to the power 6 ax plus cos to the power 4 ax dx. Now you see, this is what we have denoted by this I1, right? 0 to pi, same function, right? So t or x doesn't matter, right? Because it is definite integral. So this is I1. So that means we have got this I2 in terms of I1, e to the power pi I1. So I2 is written in terms of I1. Okay, done. Similarly, we have to find this I3 and I4, right, by the same method. What we have to do, see, I'm not doing it, so the simple method is you can substitute x equal to t minus 2 pi this term, right? 2 pi, because lower limit is 2 pi minus 2 pi, it will become 0. We want the lower limit to be 0, so you do the substitution x equal to t minus 2 pi, and for this integral you have to do the substitution x equal to t minus 3 pi. That's all. That is the only difference. So what will you do? Instead of x equal to t minus pi, we'll have t minus 2 pi. So the only difference is e to the power 2 pi. Instead of e to the power pi, e to the power 2 pi I1. Similarly here e to the power 3 pi I1. So that's all. So that means, let me write directly. So I3 equal to e to the power 2 pi I1. Similarly I4 is equal to e to the power 3 pi I1. So that's all. We found I2, I3, I4 in terms of I1. But what is required in the question? So what we need is I divided by I1. So that implies what is required is I divided by I1, right? I is this integral and I1 is what is given in the denominator. I divided by I1 is equal to, but I we have found, okay, I1 plus I2 plus I3 plus I4. So it is I1 plus I2, but I2 is written as this one, right? E to the power pi I1, similarly e to the power 2 pi I1 plus e to the power 3 pi I1. So this thing divided by I1. So this I1 gets cancelled, right? So I1 you can take out as a common factor, that gets cancelled. Now what do you get? This is 1 plus e to the power pi and e to the 2 pi and e to the 3 pi. So that is like a GP, right? So geometric progression. What is sum of GP? So we can find the sum of GP. The common ratio is e to the power pi. First term is 1. So that is simply 1, right? A multiplied by, so r to the power n, right? So r is e to the power pi. So e to the power, so 4 terms are there. So 4 pi minus 1 divided by r minus 1. So that is e to the power pi minus 1. So that is what is denoted by L. So L value is this one, e to the power 4 pi minus 1 divided by e to the power minus 1. Okay, so that's all. So that is the value of L. We have found it. Now we also have to find the value of A. What is the value of A? So A doesn't matter, right? Whatever is the value of A, so this result is independent of A. So whatever is the value of A, as long as A is an integer, right? If A is an integer, so then this result is true, right? A gets anyway cancelled, so we get L independent of A. So what is the conclusion? This A can be any integer. A can be any integer. And L has this value e to the power 4 pi minus 1 divided by e to the power 5 minus 1. So that means we got the L value, but A can be any integer, maybe 2 or 4 or 5, whatever is given in the question. So that means, so what should be the answer? Yeah, so this is the answer. Let's integrate 2 cosecant x to the power 17, right? So it is given that integral, so pi by 4 to pi by 2. Okay, so it is 2 cosecant x to the power 17 dx. Okay, yes, let us simplify this. So let us split it into two parts. First of all, let's take this 2 to the power 17 out, right? That is a constant, so we can take out. So it is pi by 4 to pi by 2 cosecant x to the power 17. So that is split into two parts. So cosecant x to the power 16 multiplied by cosecant x. Okay, so power 17, so that is written as 16 plus 1. Now we have to do some substitution, right? What substitution we can take? Can we take cosecant x as t? If you do that, then its derivative dt is cosecant x cot x. So that is not there. So we can't do the substitution. So what substitution can you take? So we have to take the substitution whose derivative is already there. If you take t equal to something, dt must be there. So but cosecant x dx is there. Whose derivative is cosecant x dx? So which function has derivative cosecant x dx? So we know the integration of cosecant x, right? So that is log cosecant x minus cot x. So let us take that as t. So t is taken as log cosecant x minus cot x. So this is taken as t. So this function is not even there in the question. It is not there in the question. But still we take this as t because its derivative should be there, right? So what is the derivative of this? So dt. So dt equals, so 1 divided by cosecant x minus cot x multiplied by, so this is cosecant x, derivative is, so minus cosecant x cot x plus cot x derivative is minus cosecant square x. Now if you do the simplification dx, so if you do the simplification, this cosecant x minus cot x, that gets cancelled, right? So cosecant x minus cot x, so what is left? So that is cosecant x dx. So that is there in the question, right? So cosecant x dx. So we can replace this cosecant x dx by simply dt. So that is why we have taken this substitution. But what about cosecant x? We don't know the value of that. We have to write this cosecant x in terms of t. So that is also important. So we've got t, but that is cosecant x minus cot x, log of that. But we just need the value of cosecant x. For that we have to do this. So t equal to this value. So log of this. So that means this value cosecant x minus. So from this what we write? So cosecant x minus cot x, that equals e to the power t. Okay, so log of this value is t. So e to the power t equal to cosecant x minus cot x. Now the next step is important. So cosecant x plus cot x. Okay, that equal to, so we should know this cosecant x minus cot x. and cosecant x plus cot x are reciprocals of each other. So this is important to know this particular expression. Cosecant x minus cot x has reciprocal cosecant x plus cot x, because if you do the multiplication of these two, what do you get? A minus b, a plus b, so that is a squared minus b squared. So it is cosecant square x minus cot square x, that is 1. So that means these two are reciprocals of each other. If you remember this particular expression, so that will be helpful in many places. So these two are reciprocal, that means this is e to the power minus t. Okay, e to the power minus t. So that means, so we've got these two relations. Now you simply add these two, we will get cosecant x, because that's what we need. So add these two. So if you add these two expressions, we'll get 2 cosecant x. So that equals e to the power t plus e to the power minus t. So in place of this cosecant x, we can substitute this e to the power t plus e to the minus t divided by 2. So that's why we're doing all this. So let us do this substitution. We will get our required answer directly, right? So that's all. So that means, so we'll get the answer 2 to the power 17. Integration limit should also be changed now. So what is the limit when x is pi by 4? So when x is pi by 4, what is the value of t? Cosecant pi by 4, that is root 2 minus 1. So log root 2 minus 1. So that is this one. So log root 2 minus 1. And then when x is pi by 2, so cosecant pi by 2, that is 1, and cot pi by 2 0, which means log 1, so that is 0. Okay, and then cosecant x, that's what we found here. So cosecant x is e to the t plus e to the minus t divided by 2. So that is e to the power t plus e to the power minus t divided by 2. So that thing to the power 16 multiplied by cosecant x dx, that is dt, that's all. So this is, okay, so that's all. This is 2 to the power 16, and here we have 2 to the power 17, so that will get cancelled. So we will get integration of log root 2 minus 1 to 0, and then this is 2, so 2 times this one e to the power t plus e to the minus t dt. Okay, so that's all. So the given integral can also be written in terms of this one, right? Exponential function. So this function is same as this function, right? This integral is same as that integral. So that is our required answer. U or t doesn't matter, right? So whatever is the variable of integration doesn't matter in definite integral. So e to the power u plus e to the power minus u du, right? So 2 times integral log root 2 minus 1 to 0, and that function e to the power u minus e to the minus u du. So that is the answer. Even this answer is not there, right? The limits are different, so we'll have to do some substitution. What we got is this one. So integral log of root 2 minus 1 to 0 to e to the power t plus e to the minus t power 16 dt. This is what we got, but this limit is not given in the options, right? So what you do, let us do some substitution. T equal to minus u. So if you do this substitution, so this lower limit becomes, instead of log root 2 minus 1, it becomes minus log root 2 minus 1. So, but what is minus log root 2 minus 1? Log of 1 by root 2 minus 1, that is same as log of root 2 plus 1. Because these two are reciprocals of each other, root 2 minus 1 and root 2 plus 1. Because 2 minus 1, right, if you multiply, so that is 1. So minus log root 2 minus 1 is same as log of root 2 plus 1, and then the upper limit is same. So 2 multiplied by e to the power minus u plus e to the power u, and dt. dt is same as minus du. Okay, so that's it. If you interchange the limits, okay, then the negative sign is gone. So we get 2 integral. So this is 0 to log of root 2 plus 1 and e power u e to the minus u du. Okay, so the power 16. So that's all. So this is the required answer. Okay, yes. Here obviously we have to do integration by parts, right? Because two functions are given, right? One is 4x cubed, so take it as u, and the other function is given as the derivative of something, or rather the second derivative of some function. So that should be taken as b, right? Let us use integration by parts to do this question. So this is the question: integral 0 to 1 4x cubed multiplied by the second derivative, right, of 1 minus x square to the power 5 dx. Now what you do, take this as u, the first function, and this is v. Let us do integration by parts. U multiplied by, which means 4x cube multiplied by, so that integration, it is already second derivative, integration of that will be the first derivative. So what is the integration of that? So d by dx. of 1 minus x square to the power 5. Okay, and the limit can be substituted 0, 1, and the second term is minus integration of du by dx, so that is 12 x square, and this as it is, right, d by dx of 1 minus x square to the power 5 dx. Okay, yes, now we have to substitute the limit. Before that, d by dx of this, so that we have to find, right, the derivative, so that is 4x cube. The derivative of this is 5 multiplied by 1 minus x square to the power 4 multiplied by minus 2x, so that is from 0 to 1. Okay, so this is the first term. Second term, to do this, again we have to use integration by parts only, because again it is integral. So this is u, this is v, so minus of, so let us use the same method, so u multiplied by integration of that, so u is what, so it is 12x square as it is. Integration of this is the derivative of something, so integration of that is that function only, so it is 1 minus x square to the power 5. Now substitute the limit 0 to 1 minus integration of derivative of this, so that is 24x multiplied by the same function, so 1 minus x square to the power 5 dx from 0 to 1. Okay, yes. Now what we do, let us substitute the limits here. See here, if you substitute the upper limit here, so 1 minus 1, 0, okay, and lower limit is also 0, so the whole expression becomes 0, minus, here also we substitute, so 12, 1 if you substitute 0, and 0 if you substitute again 0, so that is minus of 0, so then plus, you see, now this we have to do integration of, okay, how to do the integration, you have to do substitution method. What do you do, let us take some t, so t is equal to 1 minus x square, because 2x dx, so that is there, right, it's derivative, so take t is equal to this, so let us take some substitution, t is equal to 1 minus x square, so that means dt will be equal to minus 2x dx, so that is there, right, minus 2x dx, if you take out 12, so 12 multiplied, it will become plus, 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 and then integral 12 multiplied by 2x dx, that 2x dx is minus dt, so minus dt, and then 1 minus x square is what we have taken as t, so t to the power 5, the limit will also change, so when x is 0, t is 1, when x is 1, t is 0, okay, so that's all, that limit integration we can easily find, so this equals, so t to the power 6 divided by 6, or 12 t to the power 6 divided by 6, there is a negative sign, so we can interchange the limit, so 0 to 1, so that's all. If you substitute 1, 12 divided by 6, so that is 2, that's all, so that is the required answer, right. It's very simple, integration by parts, but it is very simple because it is already given as a derivative, so you don't need to integrate it, so the first derivative is given, that's integration of that is the function itself, so second derivative has integration, the first derivative of the function, so we did not do much of integration, so we've used it directly, but we've used integration by parts and we got the answer 2. Here a function capital f of x is given in terms of another function, so it is given that, so this capital f of x is integral 0 to x square f of root t dt. Okay, now obviously we have to do the differentiation. Okay, let us differentiate this both the sides, so remove the integral, that's all. So we have to use Leibniz rule. What is Leibniz rule? You just substitute the upper limit and multiply by its derivative, so that is f of, so root x square, so that is x, multiplied by derivative of x square, so that is 2x, and minus the lower limit is anyway 0, so that derivative is 0, so we can leave it. So capital f dash of x equal to f of x multiplied by 2x, but it is also given that capital F dash of x is same as small f dash of x, so this is f dash x, that equals fx multiplied by 2x, that's all, right. So let's simplify this, bring it down here, f dash of x divided by f of x is equal to 2x. Let us do the integration. Okay, so integrate. So integrate this. So what is the integration of this f dash f divided by f of x, right? The derivative of denominator f of x is in the numerator, so directly we can write, so this is the log of f of x denominator. Okay, so f dash x by f of x has integral, so log of f of x, that's all. So that equals, so this integral is x square plus constant c. Okay, now we have to find this c. For that some value is given, f of 0 is given to be 1. So let us substitute x equal to 0. If you substitute 0, f of 0 is 1, so log 1, so that is 0. that equals, and x we have taken 0, 0 plus c. So that means we got the value of c 0. Okay, so that means our required f of x is, so log of f of x is x square. Now f of x is e to the power x square. So that's all. So this is the function f of x, right? Now what is asked in the question is capital F of x, right? Capital F of 2. So for that we have to find, so substitute here. So we've got f of x equal to e to the power x square. So that we can substitute here. So this implies, so capital F of x. So that equals, so integral 0 to x square. So f of root t. So this is f of x. F of x is e to the power x square. So f of root t is e to the power, so root x square. So that is x. That's all. Okay, now do the integration. We will get the answer. E to the power x integration is, so e to the power x only. Substitute the upper limit, lower limit, etc. So e to the power x square minus e to the power 0. So that is 1. So this is the function capital F of x. So that's it. Now we want f of 2. So substitute x value here 2. So f of 2. So that equals, so e to the power 4 here minus 1. So that's all. So this is the value of f of 2, right? Simply we differentiate this. Why did we differentiate? See, when you see an integral with variable limit, we always do differentiation, right? Leibniz rule. So we just differentiated and used the relation given between the capital F of x and small f of x, and we got this answer, right? So e to the power 4 minus 1. Okay. When you get an integral having limits minus pi by 2 to pi by 2 or minus 1 to 1 or generally minus a to a, we have to first check whether the integrand is an even or odd function, right? So the given integrand here is, see, it's given that the limit is from minus pi by 2 to pi by 2 x square plus log of pi minus x pi plus x multiplied by cos x. Okay, yes. So this is what is given. Now is it even or odd function? This is an even function and this is an even function cos x, and this is an odd function, right? If you replace x by minus x, it becomes pi plus x divided by pi minus x. So reciprocal of that, log of reciprocal, that is a negative. So this is an odd function. So odd function multiplied by even function, that is an odd function. So this is an odd function. Now x square multiplied by cos x, so that is an even function. So for an even function, this limit minus pi by 2 to pi by 2, that will become 2 times 0 to pi by 2. For an odd function, minus a to a, odd function, so that becomes 0, which means we can simply remove this integral. Okay, so this, okay, becomes 0 because it is an odd function. So minus a to a, odd function, so that is 0. So this is simply 2 times integral 0 to pi by 2, okay, x square cos x, okay, dx. So that's all. So this integral you have to find. Okay, yes. So let us use the integration by parts method. So take this as u, okay, so take this as u and this is v. Okay, so let us do the integration. So this is 2 times, so this is u multiplied by integral of cos x, so that is x square sin x minus of, now the continuous integration we are doing, you find the derivative of this, find the integral of this, you keep doing this until you get 0, right? X square integral and x square derivative is 2x and sin x integral is minus cos x, okay, and then plus alternate plus minus, right? And then again we have to find the derivative of 2x, which is 2, and integral of minus cos x, so that is minus sin x. So that's all, right? The next term will become 0 because we have to differentiate this. X square derivative is 2x, derivative is 2, and whose derivative is 0. So the next term will become 0. Now we integrate this. Sin x integration is minus cos x integration is sin x. So second function is integrated, first function is differentiated. So this is the integral of the given function, but the limit is from 0 to pi by 2. Okay, so let us substitute the limits. So we get 2 multiplied by, substitute the upper limit. So we get pi square by 4, okay, pi square divided by 4 sin pi by 2, that is 1, minus, here if we substitute pi by 2, we get 0, cos pi by 2 0, and minus 2 sin pi by 2 is 1, so minus 2, okay, and then 0 if we substitute, these values will become 0, okay, so that means this is the required answer. So 2 multiplied by pi square by 4, so that is pi square by 2 minus 2 multiplied by 2, so that is 4. So that's all. So this is the required answer, pi square by 2 minus 4, right? So that's it. two functions are given, f of x and g of x, so we have to find something related to these functions. Alright, so the first one is about the function f of x. So we have to check whether this equation f of x plus 2x, so that equals 2 multiplied by 1 plus x square, right? So this equation has a root or not. If there exists some value for x satisfying this equation, so that is the root of the equation. So let us check whether this equation can have any root. Now what is f of x? So that is given in the question, so that is 1 minus x squared, so sine square x plus x squared plus 2x, so that equals 2 plus 2x squared, right? So let's simplify this further. So this is you can expand this 1 minus, so 1 multiplied by sine square x, so 1 multiplied by sine square x minus 2x sine square x plus x square sine square x plus 2x, so that equals 2 plus x square, right? 2x squared minus x squared. Okay, let's simplify this. Now this is sine square x, right? And here also x square sine square x. Here we have x square. So if you take x square common, so if you add these two terms, okay, so x square minus x square sine square x, that will become x square multiplied by cos square x, 1 minus sine square x, that will become cos square x. Similarly, we have minus 2x sine square x, here we have 2x, so if you take out 2x, so 1 minus sine square x, again cos square x, so 2x is taken out, so 2x. So if you take out 2x, so it will become 1 minus sine square x, so that is cos square x. And similarly, so here the right hand side, x square minus x square sine square x, so that will become, so let me write here, so x square if you take out, so that will become 1 minus sine square x, so that is cos square x. Now again we have a sine square x, so this is 2, so 2 minus sine square x, or you write this 2 as 1 plus 1, so 1 minus sine square x, so that will become cos square x, so it will become minus, so sine square x minus 1, so that is minus cos square x, and it's a plus 1 here. Okay, yes, so 2x cos square x minus cos square x, x square cos square x. Okay, now what do you do? So you just take out cos square x. Cos square x if you take out, so it will become x square minus 2x plus 1 equals minus 1. Okay, so bringing it to the other side. Now this is x square minus 2x plus 1, that is x minus 1 squared. So this is cos square x multiplied by x minus 1 square, so that equals minus 1. So is this possible? So this is a square of a number, right? The whole left hand side is a perfect square, that means it is always positive, so never will this be equal to minus 1. So this is not possible. For no value of x, this not possible. For no value of x, so will this be equal to this, right? So whatever is the value of x, so this will never be equal to this. This equation does not have any root. Now, so that is the first one. Now similarly, so we have the other equation, and the next one q, so this is p. Okay, so the next equation, so that is 2f of x plus 1 equal to 2x multiplied by 1 plus x square. So 2f of x plus 1 equals 2x multiplied by 1 plus x. Okay, let us again substitute the value of f of x here. Okay, so that is 2 multiplied by 1 minus x squared sine square x plus x square plus 1 equals, so this is 2x plus 2x square. From this we can find the value of sine square x. Okay, sine square x, so sine square x equal to, so this is what, 2x square minus x square, so that is x square, and then so 2x, so x square plus 2x minus 1 divided by, so this value, so 2 multiplied by 1 minus x squared. Okay, so this is sine squared x. Now will this have a solution or not? So that's what we have to check. What we are going to do is, so this left hand side is a trigonometric function, so that is an algebraic expression, so we can solve this, right, by normal method. So we use graph. So let us draw the curve sine square x and draw the curve of this function. Now if they intersect, then there is a solution. No intersection, no solution. Sine square x curve we know, so let us draw sine square x. So sine square x, right, for positive value, so always positive sine square x, right, at pi it is. So this is the graph of sine square x. Okay, so here. Okay, now what about this function? Now what we do, let us take some values, right? We need not draw this exactly, we just need to check whether this intersects that curve or not, that's all. So let us substitute some value, say 0. If you substitute 0, what do you get? So this whole thing becomes minus 1. Okay, so this at 0, this expression This value is minus 1. Okay, now at 1, what is the value? Let us find the value of this at 1. So this tends to infinity. Okay, at 1 this is denominator 0, it is infinity, but we need to know whether it is positive infinity or negative infinity. If you substitute 1 here, so this whole numerator is positive, right? So 1 plus 2 minus 1, so that is 2, so that is positive. Numerator is positive, denominator tends to positive infinity, so the whole value tends to positive infinity. Say at 1, so the value of this expression is infinity. Okay, positive infinity. At 1 it tends to infinity. That means this curve will definitely intersect at some point. Okay, so because it's a continuous function from 0 to 1, so it is not continuous at 1, but between 0 and 1 it is a continuous function. So it is a continuous function, the graph will intersect at some point, definitely. So definitely there is one solution. Do you understand? So we draw the curve, and there is a solution, which means these two curves intersect, so that means, so there is a solution. Okay, so this equation has a solution. So there is a solution for this equation. That means for some value of x, so this 2f of x plus 1 is equal to 2x 1 plus x. That means, so this is a correct statement Q, and P is not the correct statement. Okay, just so this is a continuation of the last paragraph question only. Here we have to find something related to the function g of x. We need to check whether this g of x is a decreasing function or not. For that we have to find the derivative. It is given in terms of an integral. So derivative of integral. So that means we have to use Leibniz rule. Let us find the derivative and check whether it is positive or negative. Alright, let us find the derivative of g of x. So g of x is given. So that equals integral 1 to x to t minus 1 by t plus 1 minus ln of t multiplied by f of t dt. Okay, so now let us find the derivative of this. So derivative of this integral, so use Leibniz root. Okay, just substitute the upper limit, lower limit is anyway constant, so it's not required. So 2 multiplied by x minus 1 divided by x plus 1 minus ln x multiplied by f of x multiplied by the derivative of x, that is 1, so no problem with that. Now this is positive or negative, that's what we have to check. But this f of x is already positive, because what is f of x? 2 1 x minus 1 squared sine squared x, that is the square of a number, that means it is positive. So f of x is anyway positive. We only need to check whether this expression is positive or not. Okay, so let us check whether this is positive. Okay, so forget about f of x, only this. So let us consider only this part separately. Okay, so let us take that is some h of x. So h of x equal to only this part. Okay, 2 x minus 1 divided by x plus 1 minus ln x. So this is taken as h of x. Now let us find the derivative of this, h dash of x. So that equals 2 multiplied by, so let's find the derivative of this. So that is x plus 1 square, and the quotient rule we have to use, x plus 1 multiplied by 1 minus of x minus 1. So x plus 1 minus of x minus 1. So that is just 2. Okay, 2 minus this is 1 by x. Okay, yes. Now let's simplify this. So this is 4 divided by, or 4x minus of x plus 1 squared divided by x multiplied by x plus 1 square. Okay, yes. Now is this always positive or negative? So what is this expression? This is minus x square minus 2x minus 1, but minus 2x plus 4x, that will become plus 2x. So that will become, actually it is simply minus of x minus 1 square divided by x multiplied by x plus 1 square. Okay, so let's simply, if you simplify this, we get simply this one. So this value is always negative because it is square of a number, square. So x is positive anyway, ln x is there, so positive. So the whole value is always negative. So that means negative, right? So as x is always positive, right? Ln x is there, x is positive, so this whole value is negative. Okay, so that means h of x is a decreasing function, right? So this implies h of x is a decreasing function. But we have to check whether the function g of x is decreasing or not. But h of x is decreasing function. But we have to check whether h of x is positive or negative. So we don't need to check whether it is decreasing or increasing. So it is decreasing. Now is it always positive or negative? So what can you say about this? Let us find h of say 0. Okay, h of 0. What is the value of h of 0? See, x is greater than 1. Okay, take values greater than 1. We take values greater than 1. When x is greater than 1, so h of x is a decreasing function. That means h of x is less than h of 1, right? Reverse inequality because it is a decreasing function. Okay, done. Now what is h of x? So that is this function. H of 1 we have to find. So that means h of x is less than, let's find h of 1. Substitute here. So it is 0, ln 1. So that is also 0. So h of x is negative. So h of x is negative. So h of x is negative. So that means this whole value is negative, and already this f of x is positive. So that means, so we can conclude that g dash of x is a negative for all values of x. I mean greater than 1. So x is greater than 1, it is a negative value. So that means, so this implies g of x is a decreasing function. So for in the interval 1 to infinity, because we have taken x to be greater than 1, so that means in the interval 1 to infinity, g of x is an increasing function. Alright, so that is the answer. So here in the numerator we have secant square x dx. So it is tempting to take the value of tan x to be t, so that its derivative dt will be equal to secant square x dx. But the problem is we also have a secant x in the denominator, right? So if you take tan x as t, so we have to write secant x in terms of tan x, so that will be a little complicated. So instead what we do is, so we just take the value of t, right? Let us take the substitution t equal to the whole denominator secant x plus tan x. So we take this as t. Okay, yes. Now we have to take this particular expression, secant x plus tan x is important. So this expression is t. That means what is its reciprocal? So it is better to know this one, secant x minus tan x. So that is the reciprocal of secant x plus tan x, right? So just like cosecant x plus cot x, so has reciprocal cosecant x minus cot x. Similarly we have secant x plus tan x has reciprocal, so secant x minus tan x, because if you multiply these two, you'll get secant square x minus tan square x, so that is 1. So that means, so these two are related. Okay, now what we do, so we just add these two. So t plus 1 by t, so that equals 2 secant x. So we can substitute secant x value t plus 1 by t if required. Okay, similarly if you subtract these two, t minus 1 by t, so that equals 2 tan x. Alright, yes. Now what we do, we just take the derivative of this. So what is the derivative of this? So 1 plus 1 by t square, so dt. So that equals 2 secant square x dx. So this is what is there in the numerator, right? Secant square x dx. So that can be substituted with this expression. So let us, so then the given expression will become, so integration of, so the numerator is secant square x dx. So that becomes 1 by 2. So this value, so 1 plus 1 by t square dt divided by, so denominator is secant x plus tan x to the power 9 by 2. So that means it is t to the power 9 by 2. So this is t to the power 9 by 2. So that's it. This is our expression. This can be easily integrated because we can separate this term. Only one term is there in the denominator. So 1 divided by t to the power 9 by 2. So that will become, so 1 by 2 integration of, so this is t to the power minus 9 by 2. Similarly, so this will become, so 2 plus 9 by 2. So that is, so 13 by 2. So plus t to the power minus 13 by 2 dt. Okay, so let us do the integration of this. So this will be, so t to the power minus 9 by 2. So that if you do the integration, we get t to the power minus 7 by 2 divided by minus 7 by 2. Similarly, plus this is t to the power, so this is minus 11 by 2 divided by minus 11 by 2 plus c. Okay, so let's simplify this. This 2 gets cancelled here, so we will get, so minus of, so we can take out the common factor t to the power, so minus 11 by 2. So if you take out, you will get, this is 7, so it is t square divided by 7 plus 1 plus c. Okay, so that's also, that is the integration. Now we can substitute the actual value of t, which is, so this one, secant x plus tan x. So that can be substituted here. So we'll get minus 1 divided by, so this is secant x plus tan x to the power 11 by 2 multiplied by, so this is t squared. T squared again is, so here it is 11. Okay, so there is 11 here. So t squared is secant x plus tan x squared divided by 7 plus 1 divided by 11 plus c. So that's also, that is our required answer, right? So it's very simple. So we just take the substitution t equal to secant x plus tan x, rest of the things as usual, but this one particular expression will make it easier, right? So t, you can directly also differentiate, you can find dt and directly substitute, but if you use this particular relation, so it will be easier to convert everything in terms of t, right? So this is our required answer. This is a direct question based on the properties of definite integral, right? So it is given that, so the limit is from root log 2 to root log 3 and x sine x square divided by sine of x square plus sine of log 6 minus x square. See, so looking at the question, the given expression only, we can understand it is based on the property f of a plus b minus x. You see, but first of all there is x square, so let us simplify that first. So let us take this substitution, t equal to simply x square. Alright, so that means dt equals 2x dx. So dt equals 2x dx. So that x dx is already there, so the 2 we can divide. So the question will change to simply, so x dx, so that is dt by 2, so 1 by 2 and so x dx, so that is dt, so sine x square, which means sine t dt divided by, so here also we have sine t and this is plus sine of log 6 minus t. Okay, and what about the limit? So t is x square, the square of this, so that is log 2 to log 3. Okay, yes, so that's all. So let us take the given integral to be, say, I. Now the same I is found by replacing this t by a plus b minus x. Okay, so we can do this substitution, t is replaced by a plus b minus x, but here a plus b is what? Log 2 plus log 3, that is log 6 only, so t minus t, sorry. Okay, so a plus b is log 6, so log 6 minus t. What we do? So replace this t by log 6 minus t, you will get the same expression. So that becomes the same I equals, so 1 by 2 integral, so log 2 to log 3 and sine of t is replaced by log 6 minus t dt divided by sine t, so that is sine log 6 minus t plus this becomes sine t. Okay, so that's all. So this is I and this is also I, so we have to add these two to get our required answer. That's also directly, all the terms get cancelled, so if you simply add these two terms, so we'll get 2i equal to 1 by 2 integral, so log 2 to log 3. Okay, and then this is sine t plus sine log 6 minus t, denominator same in both these cases, so sine t plus log sine log 6 minus t, so that is the same thing in the denominator, so if you add these two we will simply get 1, so 1 dt. So that's all, so that integration can be done. So I is equal to, so 1 by 4, 1 integration is x, so that is log 3 minus log 2. So that's all. So this answer is log 3 minus log 2, so this is 1 by 4 log 3 by 2. So that is the required value of I. So the value of I is 1 by 4 log 3 by 2. Here some condition satisfied by the function f of x is given, so let's find the function f of x, right? Yes, now this is the condition, so 6 times integral 1 to x f of t dt, so that equals 3x f of x minus x cube. Alright, yes, so this is the condition satisfied by the function f of x. So to find f of x, what we do, let us differentiate this, because we have an integral with variable limit, so to get rid of this integral we have to differentiate, right, variable limit, so use Leibniz rule. So let us differentiate this, so this 6 multiplied by, so you can directly substitute this upper limit, lower limit is anyway constant, right? So this equals, so here we have to use the product rule, so 3 multiplied by f of x plus 3x multiplied by f dash x minus 3x square, right? Yes, so that's it. So let's simplify this. So 6f of x minus 3f of x, so that is 3f of x, and we can also divide this 3, right? So this is f of x, that's all. So fx equals x f dash x minus x square. Alright, now rearrange these terms. So this is f of x, x f dash x minus f of x, okay? So that is equal to x square, so divide by x square. So this divided by x square, so that equals 1, okay? Yes, now if you observe this expression, so this is a very familiar expression, right? So x multiplied by derivative of f minus f multiplied by derivative of x, which is 1, right, divided by x square. Isn't it like the derivative of, this is like the quotient rule, right? So derivative of f of x divided by x, that's all. So this is u by v form. Alright, what is the derivative? X square, v squared, and then x multiplied by derivative of f minus f multiplied by derivative of x. So that's it. So this is the derivative of fx divided by x. That's all. Now you do the integration to get our required f of x. Let's integrate this. So we get fx divided by x. That's the integration. So there it is x plus the constant of integration. Okay, so done. Now let us find the value of c. So to find the value of c, what we do? Simply use the value given. So it is given that f of x is 1 by 3. So you substitute x equal to 1. So if we substitute x1, we will get 1 divided by 3 divided by x is 1. So that equals, so x is 1. So 1 plus c, so that gives you the value of c, right? So that is so 1 by 3 minus 1. So that is minus 2 by 3. So that is done. So substituting that value here, we will get f of x. So this gives you the value of f of x. So f of x equals, if you multiply, you get x multiplied by x square, and then c multiplied by x. So c is minus 2 by 3. So minus 2 by 3x. So this is the function f of x. Okay, done. Now whatever is asked, we can find it. So f of 2 is asked in the question. So f of 2 equals, simply substitute. So 4 minus 4 by 3, right? So that is same as 8 by 3. That's all. So that is the required answer, right? So f of 2 is simply 8 by 3. See, we just did the differentiation of this. See, we have to only observe this pattern, right? That's all. Otherwise nothing in this question. We differentiated to remove the integral, and this is the derivative of some function. So then integrating that, we get our required answer. So the answer here is 8 by 3. So this is a very simple question. No tricks or techniques, simple calculation. We have a polynomial divided by another polynomial. So we have to simply divide, because the numerator polynomial is of higher degree. So we have to divide it. So let us simplify the numerator polynomial and divide by the denominator polynomial, right? Simple long division method, right? That's all. Yes. Now let us write this question. So integral 0 to 1 x to the power 4, and 1 minus x, I am writing it as x minus 1, because anyway the power is even. So divided by x square plus 1 dx. So let's simplify the numerator. So it is 0 to 1. So x to the power 4. So this power 4, right? We have to use the basic binomial expansion, right? X to the power 4 minus 4c1. So 4x cube plus 4c2, 6x square minus 4c3. So 4x plus 1 dx. Okay. So divided by x square plus 1. Okay, now we have to do the multiplication. Let's multiply this. So 0 to 1, x to the power 8 minus 4x to the 7 plus 6 x to the power 6 minus 4x to the power 5 plus x to the power 4. So divided by x square plus 1. Now you divide this polynomial by this polynomial, right? So the usual long division method of dividing a polynomial by another polynomial. But instead of that, let us do some adjustments here. So we can take out some common factor, right? So that it matches with the denominator, x square plus 1. So instead of doing the long division, right? If nothing works out, you do the normal division only, right? But I am trying something like this. See x to the power 8. Now from this 6x to the power 6, you take 1x to the power 6 common, right? Take out, right? Combine that with this, right? Because if you take x to the power 6 out, that will become x square plus 1. See, it is 6, but we are only taking 1x to the power 6. So x to the power 6 plus x to the power 8, you take out x to the power 6, so you get x square plus 1. We want x square plus 1 to cancel it with the denominator. Now similarly, one more x to the power 6 can be combined with this. So, right, take x to the power x to the power 4 common. Then you will get x square plus 1. But still, we have a 4x to the power 6, right? So we have 4x to the power 6. We have taken 1x to the power 6 here, 1x to the power 6 here. So we are still left with the 4x to the power 6, okay? That we can use later. Now from the other two terms, right, these two terms can be combined. So we can take minus 4x to the power 5 can be taken out. So we'll get x square plus 1. Now still we are left with the 4x to the power 6, okay? So that we can write here 4x to the power 6. So this whole thing divided by, okay, so denominator x square plus 1, okay, dx. Now what we do, see all the terms have x square plus 1, x square plus 1. So if we divide it, okay, so that will be cancelled. So we will get something like this. So 0 to 1, x to the power 6 plus x to the power 4 minus 4x to the power 5. Okay, now this 4x to the power 6. Now what we do is, so there also we do some adjustments here. So we write this as, you add 1 and subtract 1, add and subtract 1, so that we can use the formula a cube plus b cube, a cube plus b cube, right, x square the whole cube plus 1, x square cube plus 1, that is x square plus 1, so that will be the denominator, right, we can cancel that. So that will become 4 multiplied by, so what is that term? It is like a cube plus b cube, so a plus b, so that means x square plus 1, that x square plus 1 will be cancelled with this, multiplied by the remaining, right, a square plus a minus ab plus b square. So it is like a cube plus b cube, that is a plus b cancelled, and then a square minus ab plus b square. So a square minus ab, so x to the power 4 minus ab, that is x square plus b square. So 1, and then last term is left, so minus 4 divided by, so this term x square plus 1 dx. Now all these adjustments, if you don't want to do, you simply do the long division method. You will get this as the quotient. The quotient is this, and that minus 4 will be the remainder, okay? Minus 4 is the remainder, this is the quotient, we will get it directly, but if you don't want to do this adjustments, okay? Yes. Now let us do the integration, that's all. So what do you get? X to the power 7 divided by 7. X to the power 7 divided by 7 plus x to the power 5 divided by 5 minus 4x to the power 6 divided by 6 plus 4x to the power 5 by 5 minus 4x cube divided by 3 plus 4x minus 4 tan inverse of x, okay, from 0 to 1. That's all. Substitute the upper limit. Lower limit, if you substitute anyway, all the terms will become 0, only the upper limit. So that is 1 by 7 plus 1 by 5 minus 4 by 6 or 2 by 3 plus 4 by 5 minus 4 by 3 plus 4 minus 4 tan inverse 1, so that is pi by 4, okay, so that is simply pi. Now what is this value? 1 by 7 plus 1 by 5 plus 4 by 5, so that is 5 by 5 1, so this becomes 1. This is minus 2 by 3 minus 4 by 3 minus 6 by 3, so that is minus 2, so 4 minus 2, right, so that is 2 plus 1 3, 3 plus 1 by 7, 3 plus 1 by 7 is what? 21 plus 1, 22 divided by 7, 22 divided by 7, and then there we have a minus pi. So that's all. So that is the required answer, right? 22 divided by 7 minus pi. See, there is nothing in this question. Simple. We are just doing division, right? No techniques or no different method. Just division of a polynomial by another polynomial. That we did by a different method. So you can simply divide this polynomial by this polynomial, and everything gets simplified. So we get a polynomial plus this is a known expression. We can find the integration of, right? So that will give you the answer 22 by 7 minus pi. Okay. Here the function f of x is given in terms of the greatest integer function. So let us write the function. So the function f of x is given as in, alright, so x minus integer part of x, right? X minus integer x. So that is for odd values of x. So what is x minus the greatest integer function of x? So that is the fractional part function, right? So this is the fractional part function. So that is for odd values. And similarly 1 plus integer part of x minus x, so that is negative of the fractional part x, right? So this is 1 minus fractional part x, so that is for even values. Okay, so this is the function. Okay, let us draw this function just to get an idea. Okay, so this graph will be something like this. So 0, 1, 2, 3, etc. Now if you see, so for odd values, right? So for odd values, which means integer part is an odd function, right? 0 to 1, it is an even value, right? 0, even value. So for even value, it is 1 minus fractional part x. So 1 minus fractional part of x is just this one. Okay, so at 0 the value is 1, at 1 the value is 0, right? Tends to 0. Now so this is between 0 and 1. Between 1 and 2 it is just the fractional part function. So fractional part function graph is known, right? Like this, and then again it is like this and like this. So this is a periodic function. So this is a periodic function with period 2, right? 0 to 2. So then again it repeats. So it is a periodic function with period 2. Now what about the other function? See, it is f of x cos pi x. So cos pi x function also has period 2, cos pi x, because we know cos x has period 2 pi. So 2 pi divided by pi. So this cos pi x also has period 2. So that means the function inside the integral is a periodic function with period 2. Okay, so that means, so we have to use the property of the periodic function in an integral. Okay, so what is asked in the question is this one. So pi square divided by 10 integral minus 10 to 10 f of x, okay, f of x cos pi x dx. Okay, now so it's a periodic function, but this limit, right, so minus 10 to 10, okay, so that has length, right? Length of the interval is 20, right? So 0 to 10 and then from minus 10 to 0, so 20. Now the period is 2, so that means you simply write 0 to 2, 0 to 2. Only write the integral 0 to 2 and multiply that by 10. So that will become 10 times the length 2. So that is 20, right? So we can write, that is a property of periodic function, right? So this is pi square divided by 10. So instead of minus 10 to 10, we can write it as 0 to 2 only. Only taking interval of length 2. Now that should be multiplied by 10. So totally we have length 20, right? 10 multiplied by integral 0 to 2, the same function f of x cos pi x dx. Okay, so we only have to find this integral now, because 0 to 2 we can easily integrate. So only in this interval we have to find. Okay, yes. Now what is cos pi x function in the interval 0 to 2? See, that is also of the same type only. See, this is cos pi x function. So 1, at 1, what is the value? So we are drawing cos pi x. So at 1, what is the value? It is cos pi minus 1. So 0, here minus 1. Then again it is like this. Now if you observe this, so it is pattern is same, right? So 0 to 1. Okay, 0 to 1 and then 1 to 2. It is same. So we have to find the area. So area of this triangle and this triangle. So we have to find only up to 0 to 2. So this triangle and this triangle have the same area. And this portion of cos x curve and that portion of cos x curve, they are same by symmetry, right? So this is the line x equal to 1. So right side of x equal to 1. This is the graph. Left side we have this graph. Both the graphs are same nature. You understand? So same area. So here also we have the same area. So what do? Instead of finding the area from 0 to 2, you find area only from 0 to 1. Multiply that by 2, because by symmetry we can find one part. Multiply that by 2, we'll get the area of both the parts, right? So that means instead of 0 to 2, we can find 2 times 0 to 1. Okay, so this is pi square multiplied by, so it is 2 multiplied by 0 to 1 f of x. But what is f of x from 0 to 1? 0 to 1 f of x is simply this one, 1 minus fractional part of x, right? 1 minus fractional part of x. So 1 minus, but fractional part of x is simply x. Because in the interval 0 to 1, right, in the interval 0 to 1, the fractional part is same as x only. So cos pi x dx. You understand? So let us do the integration of only this much. So we will get our required answer. Okay. So to do the integration of this, we have to use, I think integration by parts can be used here. So this is 2 pi square multiply by, so let's use integration by parts. So this is, okay, so this is u. So 1 minus x, and integration of that is sin pi x divided by pi. Okay, so that limit is from 0 to 1 minus, okay, so this integration of, so this derivative is minus 1 multiplied by integration of that is sin pi x divided by pi dx. Okay, so let's simplify this. So 2 pi square. Okay, substitute this limit. So if you substitute 1, it will become 0, and substitute 0, sine 0, 0. So this integral is completely 0, and this minus minus, so it will become plus sine pi x divided by pi. So that has integral cos pi x or minus cos pi x divided by pi square. Alright, so that is the integral of this from 0 to 1. Okay, so simplify this 2 pi square. So substitute this limit. Okay, if you substitute 0, we will get cos 0 is 1. So 1 minus, now substitute this limit. So cos pi is minus 1. So that means 1 minus minus 1 divided by pi square. Okay, so that's all. So this will give you the answer, right? This is, so 1 plus 1, 2. So 4 pi square divided by pi square. So that means the required answer is simply 4. So 4 is the answer to the question. Okay, yes. Now, so the integral is from minus 10 to 10. We reduce it into 0 to 2 because it is periodic function with period 2. So we can write 0 to 2 and multiply that by the length of the interval, right? So that's all. So 0 to 2. And then this is the normal integral, right? So that's all. So that gives you the answer 4. Yeah.